Welcome back, folks. Last example for source conversions. I promised you I'd give you one with a dependent supply. You don't see this too often, but it is possible to use source conversions with dependent supplies, so I think it's worth at least being aware that it's possible and seeing one example work through. That being said, I've never worked this problem before. This is the live act, as close as I can, even though you're watching it on YouTube. But you get to watch me maybe take some dead ends. We'll see what happens. I haven't worked one of these in a while, but I'm feeling confident. So I'm looking at this and I'm going, okay, I need to find V out. That's what I'm interested in. And but we've also got to protect IX. So we might not be able to get it all the way down to an Ohm's law problem. Let's see how far we can get it down to. Okay, so because if I convert the 3 ohm, then I lose IX, and then this supply is going to be different. So I got to be careful with that. And if I convert V out, the same problem. I'm going to change my output voltage, and that would be wrong. Okay, so what I notice first is that this is a Norton equivalent, and if I convert it, I'm going to end up with a voltage supply that's in series with this dependent voltage supply. I like that. Just because one's independent and one's dependent doesn't mean I can't combine them. It just gets a little messy in how I do it in the writing, but you'll see that in a moment. And then that'll also give me this 6 ohm in series with that 4 ohm, and I like that. I can combine those two as well. So I'm going to make that conversion for starters. We'll see if I'm right without thinking too much further ahead. There we go. So there's my Norton. And let's convert that to a Thevenin. Okay, so I already have a pre-made copy of the circuit here. And we're going to take all of this stuff and we're going to replace it with the Thevenin equivalent. Okay, so let's see, we've got a voltage supply and a series resistance. The resistance is easy, right? That 6 ohms moves up and it's now in series. And the voltage supply is going to be 2.5 times 6. So what is that going to be? 12.5. So it's going to be 15 volts. Okay. Feeling pretty good about that. From there, we got a lot of things in series. So like I said, this 6 ohm and this 4 ohm are in series. So let's take that, and we can combine those. Right? The 4 is in series with the dependent supply. The 6 is in series with the dependent supply. Therefore, they're in series with each other. Using the same concept, we can say that these two voltage supplies are in series, and we can combine them because they're voltage supplies and they're in series. Okay, so let's do all of that mess. I'll come back here to the original circuit, but I'm going to have to erase a bunch of stuff here and get rid of that. Okay, so I'm going to combine the voltage supplies. And when I combine a independent supply with a dependent supply, what I end up with is a dependent supply. Okay, I'm going to say plus on top, minus on bottom. Okay, and then the two resistors are going to combine and form a series resistance. So this is going to be, let's do the easy one, 6 plus 4 equals 10 ohms. Okay, I haven't touched IX, I haven't touched V out. So far I'm in good shape. We'll see what happens. This might be as far as we can get it. For the dependent supply, we're going to go, as we move up, right, we're going to move up here. So this is going to be positive 15. Okay, and continuing to move in the clockwise direction, now I move down. So it's going to be 15 minus 2 IX. Okay, and that's where it gets a little weird. I get these two individual terms. One of them is a constant, and one of them is a function of the control variable. Okay, what does that buy me? That might be it. Let me think about this a little bit, because if I convert that back, that's a Thevenin equivalent. It's a voltage supply with a series resistance. If I convert that back, I can't combine with a 3 ohm, and I can't combine these two in series because I'll lose this node in the middle. So I think I'm stuck. But 1, 2, 3 meshes, 1, 2, 3, 4, 5 nodes. What did I say? 3 meshes, 5 nodes. Okay, and this might be the example of, hey, you can't always get it down to an Ohm's law problem, but I at least got down to 2 meshes and 1, 2, 3, 4 nodes. Okay, so what do? We got rid of a mesh and we got rid of a node. And then you can go solve it. Solve it any way you want. I'll finish it just to be a completionist. I'll use nodal. That's not nodal, that's mesh. I'll use mesh. Okay. And there are no current supplies. So I'm going to write a KVL for I1. I go up 15 minus 2IX minus 10 I1 minus 3 I1 minus I2. And I'm back to where I started, so that's equal to 0. IX is my control variable. I still got to deal with that by making a substitution. Okay, so we've got 15 minus 2I1 plus 2I2 minus 10I1 minus 3I1 plus 3I2. That was just distributing all of my coefficients. Okay. Grouping like terms, there's all my I1s. So I get negative 15 I1. There's my I2s plus 5 I2 equals negative 15. Okay. KVL for I2. Let's see, we got negative 3I1 and plus 6I2 equals 0. That was using the shortcut, doing that one in my head. And I've got my 2 equations, and I've got only 2 unknowns now, which was less than when I started down this path. Okay, so negative 15, 5, negative 15, negative 3, 6, and 0. So from that I get I1 is equal to 1.2 amps. I2 is equal to 600 milliamps. What are we looking for? We're looking for V out over here. Okay, so V out, give me a little more space. V out is equal to 2 times I2. I2 is the only current that touches it. It flows in the positive direction, and then we multiply it by the resistance. So 2 times I2, plugging in the values, 2 times 600 milliamps. It's behind my head. And we get a voltage of 1.2 volts. Okay, so more source conversions. We found our first one that we couldn't get down to a single source and a single resistance. And we also had our first problem with a dependent supply. We just kind of sucked that variable into the conversion just like we would, or the combination, just like we would as if it was an independent one. It just stays as a control variable. That's the only kind of wrinkle to that. Okay, so hopefully you're feeling more comfortable with source conversions. Like I said, some people get really attached to this method and they try to throw it at every single problem, which is great. Just do it right and get the right answer. But sometimes fails, and that's when we have to go back and use mesh and nodal to really get the job done. Okay, that concludes all of the theorems we're going to look at. So we're moving on to new topics. Everything has been stationary right now, constants. Stuff has to start to move. So early in the semester, I talked about the division between statics. When you study when you MEs watching, you study everything. Everything sums to 0, and everything's a constant. And then you start studying dynamics. So we're going to start studying the dynamics portion of circuit analysis. What happens when things start to move? That's what's coming up. Stay tuned and good luck.